In this video, I'll give you some tips for solving the ALEKS problem called predicting the type of solid formed by a compound. This problem is actually kind of intense. It's not super hard, but there are a lot of things that you have to take into consideration when you're working on this problem. So in this problem, we've got 3 different elements or compounds, and we're being asked to rank these or identify the types of solids, the forces, and the melting point of each one of these solids. And so what I'd like to do is start by talking about the different types of solids. When you click on this drop-down menu, ALEKS is going to give you 3 different things to choose from: molecular, atomic, or ionic. The easiest ones to find, the ones that you should look for first, are the atomic solids. Atomic solids are going to be ones that have a formula that is just one single atom, just one individual atom. So looking at my options, this guy right here, that's got like 5 atoms in it. This one has 3 atoms in it. This is one single atom. This is an atomic solid. I do want to specify here that this is looking for literally a single atom. So it's not going to be something like H2. And that is one type of atom, but there are 2 of them, which means that it is not considered an atomic solid. So we're talking about just one single atom. Now, if you have any atomic solids, the next thing that I want you to do is identify the force holding those solids together. When you click on this drop-down menu, ALEKS is going to give you 6 different forces to choose from. Atomic solids are made up of or held together by either dispersion forces, metallic forces, or covalent forces. So even though you have 6 things available to you, if you're dealing with an atomic solid, your only actual answers are going to be either dispersion, metallic, or covalent. So how are we going to identify your force that you should choose? Well, the metallic force is the force that exists if you have a metal atom, and it's just metal atoms. If you have an atomic solid, it's going to be a single atom. That would be something like iron, or something like gold, or something like titanium, just one single atom. And if that atom is a metal, then your force is metallic. If you're not sure how to classify things as metals versus nonmetals, which you probably should be, you probably are, but if not, click on this periodic table. ALEKS's periodic table does a really good job of helping you identify metals versus nonmetals. Okay, so I don't have a metal. Neon, this is not a metal, it's a nonmetal. So that means that my force right here, my force is not metallic. Of these remaining 2 choices, I think the next easiest one to look at is going to be a dispersion force, or look for is a dispersion force, and that is going to be any atoms that are in column 8A. These are the noble gases. So 8A atoms, again, if you just pop that periodic table open and take a look at the atom that you're working with, if it is in column 8A, it is experiencing dispersion forces. That's what I have. Neon is a noble gas. It is in 8A, so that means that this is a dispersion force. And then, last but not least, if your atom, if it's not in 8A and it's not a metal, then that means that it's going to be a covalent force. So this is going to be an atom that is not a metal, not in group 8A, and not a metal. So that is, it's hard to remember, but really relatively easy, I think, to follow these different instructions to get that correct. Okay, so let's move on. After you get all of your atomic things classified and all of the forces classified, the next easiest thing for you to look for are the ionic solids. Ionic solids are going to be made up of 2 different types of atoms. The first one in the formula is going to be a metal, and the second one in the formula is going to be a nonmetal. And so when you are looking at your molecular formulas that you have left, the very first atom in the formula, you should pop that periodic table open, take a look at that. Carbon, that is not a metal. Carbon is not a metal, so that means this formula here does not start with a metal, and therefore it is not ionic. This guy, not ionic. Take a look at this formula. The very first atom in the formula is zinc. That is a metal. The second atom in the formula, bromine, that is a nonmetal. That makes this an ionic solid. Perfect. So those are relatively easy to find, especially if you have a periodic table handy. And then this is the great part. I'm going to use a different color. If you have an ionic solid, the only type of force that it experiences is ionic. So that's nice and easy, like that. Super. Now let's move on to the third type. The third type of solid is going to be molecular. And I think the easiest way, honestly, the easiest way for us to identify this is everything that we have left over. It is pretty easy. It's very easy to find the atomic solids. It's pretty easy to find the ionic solids. And if you've gone through those steps, everything that you have left is going to be molecular. So we're going to go with that. Now, the molecular things, unfortunately, these guys have a lot of different options for the types of forces that are available to them. So molecular compounds, they can experience dispersion forces, they can experience dipole forces, they can experience hydrogen bonding forces. So 3 different choices for us. Now, this part, identifying the force that we have in a molecular compound, this part is going to be more easy for you if you did really well with Lewis structures and the 3-dimensional shapes of molecules, polar, nonpolar, all those kind of things. If you're familiar with that, that's going to make this part quite a bit easier. You probably are going to want to look up or draw the Lewis structure for these different compounds. You can use the internet to look them up. That would be pretty fast. And you're going to want to attempt to classify these molecules as polar or nonpolar. If the molecule is polar, it is going to have dispersion forces. So dispersion forces are going to go with nonpolar molecule, nonpolar molecular solids. Dipole forces are going to be ones that go with polar molecular forces, molecular, with one exception. So the dipole are going to go with polar forces with one exception. Molecules that have hydrogen bonding, so these are going to be molecules that have an OH bond, an NH bond, or an FH bond. Molecules that have an OH bond, an NH bond, or an FH bond, those are all going to have the hydrogen bonding force. And again, this is where it's going to be really handy for you to actually look at the Lewis structures of these elements or compounds so that you can look for these bonds. So if you do have a molecular compound, I think probably the smartest thing to do is use the internet to look up the Lewis structure, or if you're really good at it, draw the Lewis structure real quick. Once you get the Lewis structure drawn, look for OH, NH, or FH bonds. If you find one, it's hydrogen bonding. Boom. If you do not have these bonds right here, then the next thing that I want you to do is look for an indication that the molecule is polar. I think the easiest way to do that is to look for, an asymmetry in the molecule, or look for atoms such as oxygen, nitrogen, halogens, sulfur, things that are electronegative. Those are usually indications that the molecule is polar. But again, you're going to want to check the overall 3-dimensional shape. If it is not hydrogen bonding and if it is not polar, then you're going to go with dispersion. For mine, this molecule, because it's asymmetrical, its Lewis structure looks like this. It's got that carbon-bromine bond. I am pretty sure that this is a molecule that experiences dispersion forces. Oh, no, I'm sorry, dipole forces. Because, again, I think I might have said that backwards, so I'm just going to repeat myself, or I'm going to say it again, hopefully correctly. My Lewis structure looks like this, and because I have a different bond, and so I've got carbon-hydrogen bonds, and then I have a carbon-bromine bond, which is different from the other 3, and this is a very electronegative element. This is going to be a polar molecule, so it is going to experience or dipole forces. Okay, we're almost done. So once we get the different types of forces identified, then we're able to rank these in order of their melting points, and ALEKS wants us to use a 1 next to the solid with a highest melting point. So the highest melting point, let's see if I can find a new color for this. The highest melting point is going to go with the ionic bonding. So if you have anything that is ionic bonding, where am I going to write this? I'm just going to go like this. That is going to be your number 1 highest melting point right there. That is number 1. Yes. Okay, so your next highest melting point, there's going to be a tie for your next highest melting point. It is going to either be your metal atoms or it is going to be your covalent atoms. And ALEKS is not going to give you one of each of these. So you're never going to have to worry about what do I do if I have two of these. You're going to have one or the other if you have any at all. So these are always going to be your second highest right there. And then I'm going to go with lowest. Your lowest will be the dispersion forces. So that is going to be your absolute lowest right there. And then dipole and hydrogen bonding, those are in the middle. Now, again, these are just going to give you 1, 2, 3. I'm not using the same numbers here as ALEKS. I'm saying that this, if you have one, that's going to be your highest. Your second highest would either be covalent or metallic. Your next highest would either be dipole or hydrogen bonding, and then your lowest is going to be dispersion. I've got my dispersion, so that's going to be my lowest. That's a number 3, and then that means my dipole is number 2. This is a complicated problem. I don't want to say it's hard because I know you can do it, but there's a lot of stuff to keep in your head while you're working on this problem. So be patient with yourself, and good luck.